Today we're going to go ahead and go over that last example from the 11.5 notes from yesterday. We're going to complete the 11.6 notes volume of cones, and then the homework will be a Google form. By the end of class today, you should be able to find the volume of composite solids as well as solve for the surface area and volume of cones. Go ahead and find the volume of this composite solid. So noticing we have here a triangular prism as well as a triangular pyramid. We are going to take the volumes of these two shapes, and once we find the volume of each, we'll add them together to find the complete volume of the composite solid. Starting with the volume for my prism here. So remember, when we're talking about a prism, you find the area of the base. I'm just going to show that as base, area of the base as B, and then subscript A, times the height of the complete solid. Okay, so here, my base shape is a triangle. So remember, for area of the triangle, that's 1/2 times my base length, in this case 8 feet, times my height is 4 feet. So there's my equation for finding the area of the base. And then I multiply that by the height of the prism itself, which is 5 feet. That's going to give me a volume of 16 times 5, which is going to give me 80 feet cubed. Okay, and then I'm going to go ahead and find the volume of my pyramid. Remember, for volumes of pyramid, that ends up being 1/3 times, again, the area of the base times the height of the prism. So that is going to give us that the volume is equal to 1/3 times, and the nice thing is the base shape for this triangular pyramid is the same as the base of the prism because both of these sides match up. So it's going to be the same measurements of my bases. Well, first of all, 1/2 because the triangle times my base length, again, same thing up here as down here, 8 feet, times the height of my base shape, same one as down here below, 4 feet. And then that's going to be multiplied by the height of the pyramid, which is 3 feet. So the volume there is equal to 1/3 times 16 times 3, which when you multiply all those together, you end up with 16 feet cubed. And then, of course, last step, because this is a composite solid, we're just going to go ahead and take those two volumes, add them together to give us the complete volume of the shape. So 80 plus 16 is going to give us 96 feet cubed. So now we've just calculated the volume of our composite solid. Okay, I'm going to clear that out. And now, well, of course, as always, the next slide always shows you the work, if you ever want to reference back. Now we're going to be looking at the cone. The first thing that we're going to look at is surface area of the cone. I've attached, if you open up the notes underneath the class notes tab, underneath this week, you'll see that the notes are there so you can open up to watch the video of why the equation is what it is for the surface area of a cone. And then after you watch that, go ahead and continue move on. So from the video, you should have seen that for surface area of a bright cone, you end up getting the formula that the surface area is equal to pi r squared plus pi times r times L, where L is actually the length of the slant of the cone. Okay, so now we're going to go ahead and we're going to apply that equation to the next problem. So I want to find the surface area of this right cone. Looking at it, it's given to me that my radius, if I look here, is 4 inches. And my slant is given to me of 6 inches. So I know my radius, I know my slant. That's really nice because, again, the formula for surface area is equal to pi r squared plus pi rl. And we know the values of our r and our l, so we don't have to do any hard, difficult work. And we just have to plug in what we know. So for surface area, it's going to equal to pi times my R value is 4. And then I'm going to square that value plus pi times, again, my R value is 4. And then my L value is 6. And solving that out, surface area is going to be equal to 4 squared is 16 pi times 4 times 6 is 24 pi. Adding those two together because they are multiples of pi, 16, sorry, plus, I shouldn't have done multiplication. 16 plus 24 is going to give us 40 pi. So if I wanted to state the exact answer, I would state the exact answer is 40 pi and then inches, sorry, not cubed. It would be squared because we're talking about surface area. Okay, that is the exact answer. I'm going to go ahead and clear this out and go to the next screen until you can also see the approximation. Taking all that work, if we approximate 40 pi to the nearest tenth, we get 125.7 inches squared. Oops, sorry. So for this next one, looking at our image, again, let me go through. I'm given my radius. It's 5 inches. And this time, we actually are not given outright our slant length. However, we are given the height of the cone itself, which in this case is 12 inches, and we're given the radius. And the height with the radius creates this right angle. So really, we've formed a right triangle. So we can solve for our slant length by applying the Pythagorean theorem, where the right angle points to C. So we are solving for our C. So we have 5 squared plus 12 squared is equal to C squared. And then that's going to give us 25 plus 144, which is 169. And then C squared equals 169. I'm going to go ahead and take the square root of both those sides. And C is going to be equal to, I know it's technically plus or minus 13, but we're only going to go with the positive value of 13 because we're talking about the slant length of this cone. So now we've solved for our L. It's 13 inches. Now that we have our R and we have our L, we can go ahead and apply it to our surface area equation of pi times R squared plus pi RL. And now we can just plug in our values and solve. So we have pi times my R value is 5 squared plus pi times 5 times 13. And that's going to give us that surface area is equal to 25 pi plus 65 pi, which is going to give us that surface area is equal to exactly 90 pi inches squared. So again, this is the exact answer. You can go ahead and type in 90 pi into a calculator and see what the approximation would be. I'm going to go ahead and clear this out. And so we can look at the approximation on the next slide. So the 90 pi would be approximately 282.7 inches squared if we round to the nearest tenth. So lastly, what we're going to look at is the volume of a cone. So the volume of a cone is given using the equation 1/3 times, again, the area of the base, that uppercase B to represent that, times the height of your cone. And in this case, the base shape of a cone is always going to be a circle. So we know that the equation for the area of a circle is pi r squared. So we can actually replace that big B with a consistent pi r squared, since the base shape is always going to be a circle, times the height of your cone. So given that, we have this cone here. Looking at the image, we are given our radius and we are given the height of the cone itself. So this one shouldn't be too difficult. We're going to get, again, going back to the equation, 1/3 times the area of the base. In this case, since it is a circle, it's going to be pi r squared times the height of the cone. So that is going to give us 1/3 times pi times 2.2 squared times the height is 4.5. And then that is going to give us 1/3 times 2.2 squared is going to give us 4.84. And then we still have our pi. And then that's multiplied by the 4.5. Actually, I'll put that in parentheses. And I'll put that in parentheses. Okay, and then when you multiply all of these things together, you end up with approximately 22.8 centimeters cubed, because again, we're referring to the volume. So remember to be aware of when you're using cubed versus when you're using squared. And actually, I should have showed that with the squigglies since it's an approximation. Okay. And then, similar to what we've done before, we're now going to be looking at similar cones. So just keep in mind that when we get these similar ratios, we have to cube them in order for us to do comparisons between volumes. So cone A and cone B are similar. I want to know, what is the volume of cone B? So first thing that you should have done was you should have found, you should have found the ratio of similarity just by comparing. We are given the radii of each cone. So that's going to be 9/3, which is equal to 9/3 is just 3. So our ratio is 3 or 1/3. Because remember, we could have also picked to write it 3/9, which would simplify to 1/3. Okay, so 3 or 1/3. Remember, the ratio that you decide to use in your problem is dependent on what is your goal. Are you trying to enlarge the image or are you trying to reduce it? So in this case, we know the volume of our smaller cone A, and we want the volume of cone B, which is larger. So from these two ratios, you should be choosing to manipulate the ratio of 3. And since we're talking about volume, we're going to take that similarity ratio of 3 and we are going to cube it. And that's going to give us 27. So when we take the volume that we know of cone A, 15 pi, we should then be multiplying that by 27 in order to find our solution for what is the volume of cone B. When you multiply 15 and 27, that gives you 405 pi. So if I wanted the exact answer, I would say 405 pi feet cubed, because we're talking about volume. But go ahead and you can type in 405 pi into your calculator and see what the approximation is. And we'll see it on the next screen. If we approximate, we end up with 1,272.3 feet cubed. The last thing we're going to do is we're going to find the volume of the composite solid. So we've done this already a few times. So now just go ahead and solve for the volume of this composite solid. Okay, so the two things that you should have noticed is that the two solids that compose this composite solid are a cylinder, and then we have our cone. So we need to take the volume for the cylinder. I'll just put V of C, Y for cylinder, and add that with the volume of the cone to go ahead and get the volume of the composite solid. Okay, so the volume of the composite solid. And when we do that, we end up with the volume of the cylinder. Remember, the volume for cylinder is pi times r squared, because that's how we find the area of the circle, pi r squared, times the height of the cylinder itself, which in this case the cylinder is 5. So here we end up getting pi times our radius here is 6 squared times the 5, which is the height of the cylinder. We multiply all those values together and we get 180 pi. And then we find the volume of the cylinder, which is, the volume of the cone, which is 1/3 pi r squared times the height of the cone. And so since the cylinder had a radius of 6 meters, we know the same can be said for the base of the cone because that base shape is a piece of the cylinder. It's just the top of it. So my radius here, and I'll even draw it in, my radius here is also 6 meters. Okay, so I have my R value is 6, and then I know the height of my cone. It's given 4 meters. So I have 1/3 times pi times my radius of 6 squared times my height of 4 meters. And when you multiply 1/3 times 36 times 4, you end up with 48, and then the pi. Then you can go ahead and add up those two values. 180 plus 48 is going to give us 228 pi. Approximately, that would give you 716.28 meters cubed. Again, because we're talking about volume, we want to make sure that we are cubing our measurements. And that is it for today's notes.